This is a review of scientific notation. We're going to talk about why we use scientific notation, how you can go from scientific notation to standard form to scientific notation, and how to multiply and divide using scientific notation. Looking at example A, I think we all could say that we would not want to write this number down. It took me a while to write that number that is on the board right now. This number is very long. It is a huge number. And scientists decided, you know what? It would be easier to represent this in a different way instead of writing this entire number out. Especially if you were writing a paper about something, you wouldn't want to write all of this out. It would take up a lot of space in your paper. So they came up with a system for writing out a large number. And I think it helps you to kind of compare numbers to see, well, how much larger is this number versus what if you had a number that was just 3 zeros longer? If you didn't have that nice set of threes in red, it would be a lot harder to make a comparison between the original number and the new number. When you're comparing numbers, it's difficult to do unless you think about, well, how many zeros are on the end? How large is this number in comparison to the other number? Because when you get to a certain length, it's hard to compare when it's written out in this manner. So let's go ahead and write this in scientific notation. What we're going to do is we're going to start at the very end, so where the decimal is. There's a decimal here. Afterwards, we just have zeros. And we're going to move this decimal over once, twice, 3 times, 4 times, 5 times, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. From here, I'm going to count the rest of the zeros, all right? So 22, 23, 24, 25, 26, 27, 28, 29, 30, 33, 36, 39, 40, 41, 42. So we're at 42. And then we're at 45, 48, 49, 50, 51, 52, 53, 54, 55 zeros. Then we still need to move it further. We need to move the decimal 1, 2 more places. So that's 57 places. So this is 1.25 times 10 to the 57th power. And I know you have seen this before. Basically, this means we're writing 1.25 and then we're going to multiply it by 10 and by 10 again and by 10 again and by 10 again. 57 tens is what we're going to write down. The rule of thumb is that for scientific notation to be written correctly, you can only have one number to the left of the decimal. So that could be a 1, a 2, a 3, a 4, a 5, a 6, a 7, an 8, and 9. Once you get up to 10, you now have 2 numbers in front of the decimal if you put a 10 in front of the decimal. So only numbers 1 through 9 can be in front of that decimal. Or you could just think of it as you can only have one number in front of that decimal. Of course, 0 would not count as a number, so it's got to be 1 through 9. Let's do another example. Okay, in this case in B, we have a very small number, so small, and we're going to change this to scientific notation. So we're going to move the decimal once, twice, 3 times, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 times. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40 times. 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63. I had to move it 63 times. So this is 3 times 10 to the 63rd power. And in this case, we need to make that 63 negative. Why it's negative is that is what signifies that when you change it back to standard form, you move the decimal to the left. So it shows that the number that you're representing is a very small number. So we write a negative exponent up here. Next example, C. We start with the decimal here. We move it over 1, 2, 3, 4, 5, 6 times. So this becomes 2.158 times 10 to the 6th power because the original number was a large number, so this should be positive. So we moved it 6 places, so you put a 6 here. D, 0.057, we move it once, twice. So it's 5.7 times 10 to the negative second, since the original number was a small number. And then E, we move the decimal 1, 2, 3, 4, 5 times. And this is times 10 to the negative fifth, which, knowing your exponent rules, you know that 10 to the negative fifth is the same as writing 1 over 10 to the fifth. So it's like saying 8.25 divided by 10 to the fifth power. Or you could say multiplied by 1 over 10 to the fifth. Let me write it the other way that I said it. And hopefully you all know from doing math problems up until this point in your life that when you divide by 10, the decimal is moved to the left, and when you multiply by 10, the decimal is moved to the right. And then the last example, we have the decimal on the end. We move it 1, 2, 3, 4 times. It was originally a large number, so we have a positive 4 for our exponent. And we only have one number in front of the decimal. So 5 times 10 to the fourth is your final result. Hopefully that was enough to jog your memory so you remember how to write things in scientific notation. Now we're going to look at problems that are in scientific notation already, and we're going to change them back to standard form. So we take our number 3.2, and we're going to move the decimal 4 times, and we're going to move it to the right since the 4 is positive. So we move it to the right 1, 2, 3, 4 times. There were no numbers here, but I still had to show that I moved the decimal 1 place. So we put in zeros to hold those places, and we get 32,000 for our number. So 3.2 times 10 to the fourth is the same as 32,000. B, now we have the same number 3.2, but this time the exponent on that 10 is a negative 4, so it's as if we divided by 10, divided by 10, divided by 10, and divided by 10 once more. So we move the decimal to the left 1 time, 2 times, 3 times, 4 times. We make a 0.00032, and that's standard form. C, 8.547 times 10 to the 8th, positive 8, so we move the decimal to the right 1, 2, 3, 4, 5, 6, 7, 8. So we add 1, 2, 3, 4, 5 decimals. And we get 854,700,000 in standard form. 1 times 10 to the negative 6. We have a decimal to the right of the 1, and we move the decimal to the left 6 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5 zeros. All right, 1.5932 times 10 to the negative second. I move the decimal to the left 2 places, and we get a result of 0.015932. And that's all of our examples for scientific notation. We are now going to talk about a method that we can use for multiplying and dividing when you use scientific notation. It's easier to go ahead and multiply and divide keeping the problem in scientific notation instead of writing it all out in standard form, multiplying it in standard form, and then converting it to scientific notation. So we're going to talk about now the methods that you use to figure out your results in a faster way than writing it in standard form first. So what you do is you take the 1.08 and the 9.3 and you multiply this piece. The reason why we're allowed to do this is because of the commutative property of multiplication. Here we have a multiplication sign, really. The parentheses are like a multiplication sign. So everything, every single piece is separated by multiplication. According to the commutative property of multiplication, I can switch the order when the numbers are separated by multiplication. So I'm going to switch the order here. I'm going to write this as 1.08 times 9.3, and then I'm going to multiply 10 to the negative third times 10 to the negative third. 1.08, I'm going to use a calculator and multiply that by 9.3, and we get 10.044. Then I'm going to multiply that by 10 to the negative third times 10 to the negative third. When the bases are the same, you add them up. So you add up the exponents. So it's going to be 10 to the negative third plus a negative 3. And this becomes 10.044 times 10 to the negative 6. When you're finished multiplying, you need to check and make sure that it's still in scientific notation. If you look at this problem, you will see that in front of the decimal, we actually have 2 numbers in front of the decimal. So we need to change this back to scientific notation. To do so, we move the decimal to the left 1 place. So if I move it to the left, I'm going to consider that a decrease. It went from 10.044 to the number 1.0044. Let me write that more neatly. 1.0044. So it went from a 10 to a 1, approximately. And then this will be times 10 to the power of, and what happens to this is we increase this by 1, and this becomes a negative 5. You always do the opposite. If you decrease this by 1 place, you increase this value by 1. So your final answer is 1.044 times 10 to the negative 5th. Let's complete another multiplication example. We'll work on number 2. Once again, you're going to reorder. So we're going to multiply 2 times 8.1. And then we're going to multiply 10 to the negative 4th times 10 to the negative 1st. So first of all, we take 2 and we multiply it by 8.1, and we get 16.2. And then when the bases are the same, you add the exponents. So we get 10 to the negative 5th. From here, we need to change this to scientific notation. So we move the decimal to the left 1 time so that now we only have 1 number to the left of the decimal, and we get 1.62. Since we decrease this, we could say by 1 place, we're going to increase this by 1 place. So this is now going to be times 10 to the power of negative 4 instead of negative 5. So 1.62 times 10 to the negative 4th. Now let's see how much time we have left. We're at 13 minutes. So we'll do one more multiplication problem. And then the next video I'll do a division problem. So 3.48 times 9.8. 3.48 times 9.8, you get 34.104. And then we go ahead and we multiply 10 to the third times 10 to the fourth. When the bases are the same, you add them up and you get 10 to the 7th power. I need to move the decimal to the left 1 place to change this to scientific notation. When I decrease this by 1 place from 34 to 3, it's a decrease. Then I need to increase this by 1, so it's times 10 to the 8th power. So your answer is 3.4104 times 10 to the 8th power. And that's all the time we have in this video.